Hi algebra students, this lesson is about the Pythagorean Theorem. And before we get into what the Pythagorean Theorem is, we need to talk a little bit about what the Pythagorean Theorem works with. And the Pythagorean Theorem will help us with right triangles. And remember, a right triangle is a triangle that has one 90-degree angle. So what we'll be able to do is we'll be able to find all three side lengths, if we know two of them, of a right triangle. And then later on in the next lesson, we'll be able to determine if a triangle is right or not right based on the side lengths. So a little bit of vocabulary, and you'll fill your notes guide in as we go. So your first vocabulary word is opposite. And an opposite side or angle in a triangle is going to be across from or away from that side or angle. Okay, so if you think about opposite sides of the room, things like that, you can think about opposite in regular non-math life. So in a triangle, an opposite side does not touch its opposite angle. Our next vocabulary word is adjacent, and adjacent is really the opposite of opposite. Adjacent means next to or alongside. So the person you are sitting next to right now, you are adjacent to that person. And in triangles, an adjacent side does touch, runs into the angle that it's adjacent to. And so you can see this little diagram. It's not on your notes page, but you could draw it if you wanted to off to the side. So you can see in this triangle, and it's not a particular triangle, we have these two sides that are marked in red, and they both run into this angle right here. And so they are adjacent to that angle because they both touch that angle. Then we've got this purple side across, that's all the way across. This purple side does not touch this orange angle up here, so it's opposite that angle. So our next vocabulary word is hypotenuse. And a hypotenuse is a particular side in a right triangle. So a right triangle is indicated with this little square. That's our 90-degree angle. And the hypotenuse is the side that's opposite the right angle. It's also always the longest side in a right triangle. So hypotenuse is specific to right triangles. The other thing about a hypotenuse is I've mentioned that it's the longest side. So one way to remember it is hypotenuse kind of sounds like hippopotamus, and a hippopotamus is a very large animal. So you could say that the hypotenuse is the longest side or the largest because it's the hippopotamus of the right triangle. Now in a right triangle, we had hypotenuse, but we also have legs. So this was our first word, and now legs are our second word. And the legs are the other two sides of a right triangle. They're always adjacent to the right angle, so they both run into the right angle. So there's the hypotenuse that's across from, and then the adjacent sides run into it. And so then finally we'll put it all together and we'll be able to talk about right triangles. And so we'll be using the Pythagorean Theorem. And what the Pythagorean Theorem does for us is it allows us, if we know two out of these three sides, we can always calculate the third using the Pythagorean Theorem. And so what we have is we have this relationship, a squared plus b squared equals c squared, and you've probably heard that before and probably used it before. The key here is that the number by itself, c squared, the sum squared, is always the hypotenuse. So c, the one that's being added, is the hypotenuse. The Pythagorean Theorem only works with right triangles. We can't use this on some other kind of triangle, but if we have a right triangle, it's really nice. Okay, so now on your notes, you've got these three triangles, and notice that it says the figures are not drawn to scale, so don't rely on that. I didn't measure 7 and 24 and stuff like that. However, what we do know is we see the little square mark in one of the angles. That tells us that these are all right triangles. So because they're right triangles, we can use the Pythagorean Theorem to find the missing side lengths. So in our first example, we're looking for this side length. Notice it runs into the right angle. So that means it is not the hypotenuse. Okay, and so that's very important. So let's first label our sides in terms of You can use A, B, and C. We can also label in hypotenuse, wherever the hypotenuse is. The hypotenuse, remember, is always opposite the right angle. So in this case, 9 feet, that's our hypotenuse, and I'll just abbreviate with hyp. That's important. So that tells us that that side length is C. Then the other two side lengths don't matter. We don't care which one is A or B because they're being added in addition. Is commutative, meaning it can go in either order. So we can make this side A and this B, or we can reverse that. That's up to you. So remember, we have that relationship, A squared plus B squared equals C squared. So now what we'll do is we'll replace A, B, and C with the values given from the diagram. So A in our diagram is x. So we're going to write x squared instead. B is 7. I'm going to leave the units off for now, although we'll see that we'll have the same units for everything. Okay, so we have feet, so in the end when we write it, we're going to need to include feet. So we have 7 squared, and then equals, our C is 9, so 9 squared. Now what we can do is we can solve this equation. So we've got x squared, remember your order of operations, you have to square before you can do any addition, subtraction, multiplication, or division. So we have x squared plus 49 equals 81. So we'll subtract 49 from both sides. And we'll do that subtraction. And so then from here, we will square root both sides. And if you remember, when we square rooted to solve equations, we needed to include plus or minus. And so we could have more than one answer. Well, right now, we would do that because we're in algebra class and we're remembering to include the plus or minus. But then let's look back up here. We're looking for a side length in feet. Have you ever seen a ruler with negative measures on it, negative inches, negative feet? You haven't, because it doesn't exist. So because this is actually measuring a distance, we're going to get rid of that. We only need the positive. All right, so then we can write our answer in two different ways. One way, we can find the decimal. Just use your calculator. So we're going to take the square root of 32. And we get approximately 5.66 feet. I rounded to the nearest hundredth. On the calculator screen, it says 5.6568. And so I rounded the 5 up to a 6 because the number next to it was 5 or larger. So that's one way that we can write our answer. The other way, if I asked for an exact answer, this is approximate. So if I wanted an exact answer, that would involve a simple square root. So we're thinking 32 is 16 times 2, and 16 is 4 times 4. So the 4 would come out, the 2 would stay in. I'll try to squeeze this. So we can also say that x is 4 times the square root of 2. All right, we'll try one more together, and then, because this one's a little bit different, and then I'll send you off on your own. So on this one, the missing length, if we highlight that, this time it's opposite the right angle, where on the first example, it touched the right angle. Since it's opposite the right angle, that tells us that we have the hypotenuse. So we have C. And then again, it doesn't matter which letter you use for your two legs. So again, we're using a squared plus b squared equals c squared. And it's really helpful to continue writing that. It does two things for you. One, it helps you memorize it. And two, it gives you that visual of exactly what you're plugging into. Okay, so I have my A, which is 24, squared, plus B, which is 7, squared, equals C squared. So to solve this one, we need to square both of these. So you're using a calculator. So we have 576 plus 49 equals C squared. So we find out that C squared is 625. And again, we're going to square root both sides, and we're looking for feet. So because we're looking for feet, we don't need the plus or minus. We're just going to find the positive. So you'll find the square root of 625, which it happens to be a perfect square. So here we say C is 25 feet. And I just realized on my last one, my 4 root 2 should be feet. So I'll add that in. So go ahead and try number 3 by yourself, pause the video, and then check in and see how you did. So on this one, when I drew in my missing side length, I can see that it ran right into that right angle. So it could not be the hypotenuse. So all the way across from the right angle is the hypotenuse. So in this case, our length 41 feet is our hypotenuse C. Then the other two, it doesn't matter which one you picked for A and B, because we'll replace them in these two locations. So that doesn't matter. So then I wrote out my Pythagorean theorem, and I substituted. My A was here, yours might have been here, that's okay. So we get x squared plus 9 squared is 41 squared. I squared 9 and 41, I used a calculator. I subtracted 81 from both sides, and then I square rooted 1600, and so then we end up with 40 feet. For our next 3 examples, and really the next 4 examples, will include 7 in this, it says to draw and label a sketch before solving your problem. So we do have to draw and label a sketch for each problem, it's required, and then we'll write out our equation. In problem 4, we're given side A, and I'm about to give you side B. Side B is 24, so write that in. So what we're doing is we need to solve for the missing side. So we're looking for C. Okay, and up here it's saying solve for the side not given when the hypotenuse is C. Okay, so that's important. So we know C is still the hypotenuse because those are arbitrary letters. So the first thing that we'll do is we can draw and label a triangle. And you can draw yours as long as it's a right triangle in almost any way. So make sure you include the little right angle. Okay, and that should look like a 90-degree angle as well. So we know side lengths A and B. Now I'm going to try to make my diagram semi-realistic. So I want my side that's 24, that's bigger, to be my longer side. So I'm going to say this one's 24, which is B. So this one's got to be A, which is 10. The reason I knew they had to be those two is because, remember, C, the hypotenuse, is opposite the right angle. So in this case, we're looking to find the hypotenuse. And so remember, we're using A squared plus B squared equals C squared. So we can replace. Our A is 10. So 10 squared plus our B is 24 squared equals C squared. Okay, so you had a lot of practice. Go ahead and solve this one. Pause if you need to. I'm just going to do it out so you can kind of follow along. So I'm going to square 10 and 24. We've got 100 plus 576 equals C squared. So 676 is C squared. And so then you can square root both sides. And we're looking for lengths. So this entire unit, we're just going to be looking at the positive square root. So on your calculator, you can square root 676, and you can find out that C is 26. Now, these didn't have units. It's not feet or inches, so if it's not given, then I'm okay with you just leaving it. Some math teachers make you write the word units, but I don't. So if we take a look at problem 5, we're given sides A and B again. This time A is 5 and B is 12. Go ahead and write that down. So just like the last one, draw a diagram with this. Remember, we're solving for C. Okay, so go ahead and set up your diagram. Pause the video so you can set it up and then check back in. Okay, so we were given the two legs again, A and B. We're looking for the hypotenuse, and I just made my longer one 12 because 12 should be longer than 5. Then I've written out the Pythagorean Theorem, and we can substitute our values in. Our A is 5, so we'll have 5 squared. B is 12 plus 12 squared equals C squared. Now go ahead and solve for C on your own, and then check back in. So you're going to pause now. Okay, so I squared 5 and 12 to get 25 and 144. Then I added them, and then I square rooted both sides. So what we see here when we have all three side lengths in a right triangle, where they're integers, not decimal or radicals, we call those Pythagorean triples, if all three are non-decimals, if they're integers. All right, so our last problem in this particular group, we have A, 9, and then C is 15. This time we're looking for B. Okay, so when we draw our diagram, this time C, opposite the right angle, is given. Then it doesn't matter which other side we label, so I'm just going to label the small side as 9. So that's A, which means that the other side is B. Okay, we're going to use the Pythagorean Theorem again. A squared plus B squared equals C squared. And if you really, truly write it out every time, there's no way that you won't remember it. And it really makes it so that you're less likely to make mistakes. So now we'll substitute our values in. Our A is 9. We don't know B, so we'll use the letter. And C is 15. Don't forget your squares. So now we'll say 81 plus B squared equals 225, 15 squared. And then we'll subtract 81 from both sides. This is very similar to our first example. So then we have B squared is 144. From here, we'll square root both sides. And we have another Pythagorean triple. B is 12. Okay, in example 7, it's just like the previous examples, except that we're given words instead of A equals B equals. So this is saying find the length of the other leg. So that's going to be either A or B. Of a right triangle if the hypotenuse, remember the hypotenuse is C, is, and I'll give you 37 inches long. So C here is 37. And it says one leg is 12 inches long. So let's just decide that we're going to use A or B here. Why not A? So then what that means, we're looking for the other leg. So we're looking for B. All right. You can make an organized list if that helps you. We are required to draw a triangle, and I thought I'd mix it up this time and draw it the opposite direction. Whoa. Okay, so we have a little right triangle. We've got our right angle. We know our hypotenuse, C is 37, and we know one of the legs. So let's just make it the short one. It doesn't really matter. And then we'll solve for the missing one. So we're going to do this just like the previous 3 problems. So go ahead and do the rest of the problem, writing out the Pythagorean Theorem, substituting in, finding what that length of the missing leg is. So I wrote out the Pythagorean Theorem. I substituted 12 for A. We don't know B. And I substituted 37 for C. I squared 12, getting 144. I squared 37, getting 1,369. Then to solve this, we need to subtract 144 from both sides to get B squared by itself. And when we subtract, we get 1225. So then we can square root both sides, and the square root of 1225 is 35. Then I'm remembering to look back in the problem for my units. We have inches for the two side lengths, so we're going to have inches for our missing side length. Okay, in our last two examples, we basically have two problems in one, or two triangles in one. So, and really three, but what we're going to focus on are two of them. So we have this missing side length x, and it's part of this right triangle, and it's adjacent to the right angle. We also have our missing side length y that's opposite, so that's going to be a hypotenuse. But then we also have this triangle. And because these two triangles share that angle, even though it's not drawn, we know that that's also a right angle. So what we can do is, we know two side lengths in the smaller, the one I made blue triangle, so we can find the third. So x is a leg in both of these, so we can call it A, where later y is going to be the hypotenuse, so y will be C. So I'm going to focus just on this smaller triangle first. Okay, in that smaller triangle, C is 17. So we can solve for x using the Pythagorean theorem by plugging in. So I'll write it out. So we have x squared plus 8 squared equals 17 squared. So we have x squared plus 64 equals 289. We can subtract 64 from both sides. So x squared is 225. We'll square root both sides. So we find that x is 15. But we also need to find y. So now I'm going to focus just on this triangle. All right, so I've written the Pythagorean theorem, and this time y, the unknown that we're looking for, is our hypotenuse C. Also, even though it says on here x is A, x is really 15, or A is 15. So we can replace and say 15 squared plus b 36 squared equals our unknown y. And so then we can square 15 and 36. So we'll have 225 plus 1296 equals y squared. We'll add those together. And then we can square root both sides. And we'll see that y is 39. Our last problem is very, very similar. You're going to split it into two separate triangles. So I'll help with that part. We've got this right triangle, and we've got our smaller but also right triangle. Okay, so again, start with the right triangle that we know two lengths of. So it's going to be the smaller triangle again, because we know 25 and we know 7. We can't start with this triangle because we have two unknowns. So you're going to start over here. So go ahead and solve this triangle for both x and y. You can use problem 8 as your guide to help you out. So pause the video now. Try your best. If you need to, unpause and you can see my explanation. So I started off on this problem with the smaller right triangle, like I said, and I used a squared plus b squared equals c squared. I had to do the problem twice. So on the first problem, we're looking for x, and we don't know yet that it's 24. So that's not the hypotenuse. So we're going to write out 7 squared plus x squared is 25 squared, the hypotenuse. So I squared 7, I squared 25. And so then I can subtract 49 from both sides. So then I have x squared is that difference 576. I square rooted both sides and found that x was 24. So I added that into the diagram. Then I went to solve the larger triangle over here. And again, I'm using a squared plus b squared equals c squared. And this time my unknown is still one of the legs, so I just called it a. So I said y squared plus the newly found 24 squared equals a hypotenuse 30 squared. I squared 24 and I squared 30. Then I had to subtract 576 from both sides to get y squared by itself. So I found that y squared was the difference, 324. Then I square rooted both sides and found that y is 18. So now you can use the Pythagorean theorem to solve for a missing side length in a right triangle.